Building a faceless YouTube channel system is one thing, but running it reliably, end-to-end, on a daily basis, is another challenge entirely. I've been refining this process for months. My initial setup involved a series of disconnected Python scripts. I'd run generate_script.py, wait, then synthesizeVoice.py, wait, then generate_images.py, and so on. This quickly became untenable. A single failure at any stage meant I had to manually restart the entire chain, often from scratch. The primary problem was a lack of unified state management and fault tolerance. If synthesizeVoice.py failed due to an API rate limit, I'd have to figure out where it stopped, rerun it with specific parameters, and then manually kick off the next stage. This wasn't automation. It was a glorified task list. What I needed was a true orchestrator, a single entry point that knew the entire workflow, maintained state, and could gracefully resume from any point of failure. My goal was a single command: Python Orchestrator.py topic AI in medicine. This command should handle everything from generating the initial video script to uploading the final MP4 to YouTube. The core idea was to break the pipeline into discrete, idempotent stages. Each stage would perform a specific task and, critically, persist its progress to a central data store. If a stage failed, the orchestrator could query the store, identify the last successful step, and restart from the next logical stage without redoing already completed work. This design pattern has been a lifesaver in every long-running automation project I've tackled. For state management, I opted for SQLite. It's lightweight, embedded, and perfect for a single machine. Long-running process like this. I created a simple pipeline runs table with columns like runid, topic, status, current stage, output path script, output path audio, output path images, and YouTube video. Each time I initiate a run, a new entry is created. As each stage completes, the current stage and relevant output path columns are updated. If execute a stage.script generation completes, I update the output path script field with the path to the generated script, and set current stage to voice synthesis pending. This gives me a clear audit trail and, more importantly, a reliable point to resume from. The script generation stage is handled by Claude. I use Anthropic's Messages API, specifically targeting Claude 3 Opus 20,240,229. I feed it a structured prompt, instructing it to generate a video script with a specific number of scenes, each with a title, narration, and an image prompt. The key here is error handling. I wrap the API call in a try-except block, specifically looking for anthropic.api error or http://connect error. If an error occurs, I log it, update the status in SQLite to failed, and exit. The orchestrator, on its next run, will detect the failed status and not attempt to regenerate the script if it already exists, unless explicitly told to force a restart. This robustness is crucial given the cost and time involved in API calls. Next, voice synthesis. I'm using PlayHT's API for high-quality synthetic voices. For each scene's narration generated by Claude, I send a separate API request to PlayHT. This produces individual MP3 files for each segment. I prefer this approach over a single large audio file because it simplifies later video editing and allows for easier retries if one segment fails to synthesize correctly. The cost here is per character, so efficient use of the API is important. Again, try-except blocks are in place to catch plate.api error and requests.exceptions.connection error. If any segment fails, the entire voice synthesis stage for that run is marked as failed in SQLite, preventing the next stage from starting with incomplete audio. Image generation uses Midjourney. Since Midjourney doesn't have a direct API in the traditional sense, I've built a small wrapper around a Discord bot interaction. It's a bit more involved, but it works. For each image prompt generated by Claude, I send it to my Discord bot, wait for the image to be generated, and then download the highest resolution version. This stage is by far the slowest due to the asynchronous nature of Midjourney's generation process. To mitigate this, I implement long timeouts and retry mechanisms. If the image isn't ready after a certain period, I'll poll again. If it consistently fails, the run is marked failed. The orchestrator stores the local path to each generated image, linking it back to the specific scene. Video assembly is where MoviePy comes in. I gather all the synthesized audio files and generated images. Each scene becomes a composite video clip consisting of an image as image clip, and its corresponding audio file clip. I arrange these sequentially, adding simple transitions like fades between scenes. The orchestrator ensures all necessary assets, scripts, audio, Images exist before the stage begins. If any asset is missing, it'll indicate a prior stage failure. The final output is an MP4 file, ready for upload. This stage is compute-intensive, especially for longer videos, so I ensure appropriate system resources are available. Once rendering is complete, the path to the final video is updated in the pipeliner runs table. Finally, YouTube upload. I use the Google YouTube Data API v3. This involves OAuth 2.0 for authorization, obtaining credentials, and then using the youtube.videos.insert method. I pass in the video file, title, description, and tags generated earlier in the pipeline. The Orchestrator updates the SQLite database with a returned YouTube video upon successful upload and sets the status to completed. This entire process, from a single command to a live YouTube video, is now fully automated and resilient. It greatly reduces the manual oversight required and has allowed me to scale up content production significantly without increasing my direct effort. This is the kind of automation that truly empowers small, independent builders. If you're interested in the full codebase for this Orchestrator module, let me know by hitting that like button, and I'll consider open sourcing it in a future update.